acids and buffers. So we're looking at acids and buffers. We will look and focus at a few questions on this topic. We'll look at about 3, maximum of 4 questions. So few important points to note first. pH is minus log to the base 10 of H plus. In other words, to work out pH of any solution, you need to know the concentration of hydrogen ions. If you have a strong acid, then the concentration of the acid equals concentration of H plus. If it's a monoprotic acid, HCl, then its concentration is H plus. If it's diprotic, then the concentration of hydrogen ions is 2 times the concentration of the acid. If it's a weak acid has something called Ka, which is known as the acid dissociation constant. It gives us information about the degree of weakness or strength of the acid. It is expression H plus, A minus, your salt, and the acid. That's the expression. For calculation purposes, because it's a weak acid, A minus equals H plus, so we reduce that expression to H squared expression. We'll do an example to look at how we work that out. If we're looking at a base, then we must use the Kw formula for the base. So my aim is not how Kw was derived. You've got to know that part, but I'm giving you the examples of how to work out pH. So now let's look at the question in hand. The question in front of us says nitric acid is a strong acid. We should know nitric acid is monoprotic. So the pH equals minus log 0.150, because that is the pH, that is the concentration of nitric acid, and that gives you an answer of 0.82, and note 2 decimal places. So that one, strong acid done. Now let's look at a weak acid. Propanoic acid is a weak acid. So propanoic acid has 3 carbons, 1, 2, 3. So make sure you can draw structures of acids. If any confusion, go back to the carboxylic acids topic for that. It's a weak acid, so you've got to show the arrows, and then it dissociates as that. Ka, so let's write the expression. Whenever you are doing weak acid calculation, you must always start with the expression and then say H plus squared. Okay, now what information do I have? I know the pH and I know Ka, and I need to work out concentration. So in other words, the concentration of the acid equals H plus squared over Ka. H plus squared is going to be 10 to the minus 2.89 squared divided by your Ka, which is 1.35 times 10 to the minus 5. So remember, if you know pH, then to work out H plus, if you're old-fashioned like me, I do the following on my calculator. I press the shift button, then I press the log button on my calculator. So my calculator is a Casio. So when I press log, I see a small 10, and then I just do minus 2.89. That gives me 1.288 times 10 to the minus 3. I'm going to square that expression and then divide by 1.35 to minus 5, and that gives me an answer of 0.1229, but I'm just going to give the answer to 3 significant figures. So that's weak acid, and we've just done the strong acid. Okay, now let's move on to the buffer, because the buffer is the one that often causes problems. And the reason for a buffer, and let's explain the buffer like this. So a buffer is formed by a weak acid and its salt. So that would be, let's give you the example of ethanoic acid. And the salt of ethanoic acid is CH3COON, so sodium ethanoate. The salt can be formed by acid plus base like sodium hydroxide. It can be formed from acid plus sodium. Other bases, sodium carbonate, they can form the base. They can form the salt. Salt dissociates completely. There's a reason I'm doing color coordination here. When we add the acid and the salt together, you get this. The sodiums cancel. The ethanoate cancels like this. And then you've got that, and that now is your buffer expression. The point I want to make here with the buffer expression is that in a buffer, the acid and the salt contribute to the buffer. And the reason that happens is, the reason you need to know that is because a buffer is different to a weak acid. In a weak acid, an acid dissociates into a salt or into the ethanoate ion, and then we make this assumption of the expression Ka equals H plus squared. So that's the key thing. Now, if a acid is added to the buffer, then the equilibrium shifts to the right to remove the added hydrogen ions. And if a base is added to a buffer, then the equilibrium will move to the when the base is added, the base, sorry, let me get this right. When the base is added to the buffer will move, or the equilibrium will move to the right. When the acid is added to the buffer, H plus increases, that reacts with CH3OO minus, and the equilibrium will move to the left. So base added to the buffer, equilibrium moves to the right hand side. Acid added, equilibrium moves to the left hand side. Ignore the first point I made there, my apologies. Okay, now let's look at the calculation. Now please come up with this expression. To work out the pH of a buffer, H plus equals acid over the salt. The question states 0.65 of sodium ethanoate. So the moles of, I'm just going to call this A minus, is 0.656 over 82. That's your moles. And if you look at your acid concentration, it's 0.12. So your acid has a concentration of 0.12. So let's work out the moles of A minus or ethanoate, which is 0.008, and the moles of the acid is concentration, okay, concentration times volume over 1000, which comes to 0.003 or 3 times 0.006, sorry, okay, and the moles of HCl added is 0.2 times 1.5 over 1000, and that comes to 3.0 times 10 to the minus 4. All of these are significant now. So what I want you to understand here is that when HCl is added to the buffer, then the moles of weak acid increase and moles of the salt decrease. And if sodium hydroxide was added, then the moles of the acid would decrease and the moles of the ethanoate would increase. So now let's work out new moles. New moles of A minus 0.008 minus 3 times 10 to the minus 4, and new moles of acid is 0.006, add 3 times 10 to the minus 4. The buffer is maintaining its pH, or sorry, the buffer is maintaining the pH. So 0.008 minus 3 to minus 4 equals 7.7 times 10 to the minus 3, and 0.006 add 3 to the minus 4 equals 6.3 times 10 to the minus 3. Now H plus, so now let's work out pH. So work out pH. Ka is given right at the top, 1.78 times 10 to the minus 5 times new concentration of the acid. I'm just going to do V. I don't need to work out the new concentration. I am showing my working out. Concentration is moles over V. It's a buffer. So in the buffer, your volume is the same. So V cancels. So 1.78 to minus 5 times 6.3 to minus 3, and then divide that by 7.7 to minus 3. That comes to 1.456 times 10 to the minus 3, and then pH equals minus log 1.456 times 10 to the minus 3, and I get an answer of 4.84. That means that initial pH was 4.87, so my change is 0.03. That's how you would do a buffer calculation. Very important, you pause the video to watch what's going on. So I worked out moles of the salt, moles of the acid, then I worked out new moles when HCl is added. The moles of A minus goes down, the moles of acid goes up. Then substitute into the formula. So that's a calculation there. Now the next question is another very, very popular question, which is an acid-base question. Look, acid-base. Key information here. You know the volume and concentration of sodium hydroxide. It is mixed with hydrochloric acid. You need to know now that this is a 1:1 molar ratio. So in this calculation, number 1, work out moles of hydroxide, work out moles of acid, then work out excess moles. It's very important that when you have a titration calculation of this nature, where the volume, where the moles can be calculated for both. So 35 times 0.15, so you're going to do 0.15 times 35 over 1000. That gives you the moles of hydroxide. And 0.1 times 20 over 1000 is going to give you the moles of acid. And let's work out the excess moles. So the moles of hydroxide is 5.25 times 10 to the minus 3, and the moles of acid comes to 2 times 10 to the minus 3. So excess moles is, now the excess moles is of course 5.25 times 10 to the minus 3 minus 2 times 10 to the minus 3, which comes to 3.25 times 10 to the minus 3, and the excess moles is hydroxide. So new concentration of solution now. The question says, what is the calculate the pH of the solution formed. So the new concentration solution is the moles divided by total volume, which is 55. Total volume. You are working out the pH of the new solution. 2 times 10 to the minus 3 moles of HCl has reacted with 2 times 10 to the minus 3 moles of hydroxide, which means 3.25 times 10 to the minus 3 moles of hydroxide remain. So we're working out the new concentration of the solution, the remaining solution, which hasn't reacted yet, and that comes to 0.0591. Now here's really important point, because since and let me write in a different color, since hydroxide is in excess, to work out concentration of H plus, you use Kw. So H plus equals Kw over hydroxide concentration, and Kw in the question is given as 2.92 times 10 to the minus 14. So 2.92 times 10 to the minus 14 divided by 0.0591. It's very important you don't use 1 times 10 to the minus 14 here. And you get an answer of 4.94 times 10 to the minus 13, and then your pH is minus log of your H plus, and that comes to 12.31, and that's how you would do that calculation. Okay, now and you can see now a question comes here where butanol, where it's a weak acid calculation, weak acid strong base calculation. Again, you would do the same thing. You work out moles of sodium hydroxide, moles of acid, then you work out excess moles. And in this question, the acid is in excess, and because it's a weak acid in excess, you will use Ka to work out H plus. After you work out new concentration, and then you follow the same procedure, minus log 10, and you should get an answer of 5.42. So I'm going to leave the question there. So you know that the question is that it will help you to calculate on that. Now let me go into one more question on buffer. So here, so this buffer carries 5 marks. So this is my last question now. A buffer is made by adding 2 grams of sodium hydroxide to 500 cubic centimeters of 1 molar ethanoic acid. Calculate the pH of this buffer. So it's sodium hydroxide is added to ethanoic acid. That means the moles of sodium hydroxide equals moles of your salt. Sodium hydroxide dissociates completely. So moles of sodium hydroxide is 2 over 40, which is 0.05 mole. That becomes the moles of the salt. At this stage, you've got to be able to know your equation for buffer. So that moles becomes 0.05. Now, what about the original moles of ethanoic acid? And that will be 1 times, so remember moles is concentration times volume, 500 over 1000, which is 0.5, so that becomes 0.5 mole. Now the moles of ethanoic acid in the buffer, in other words, after adding sodium hydroxide, will be 0.5 minus 0.05. Remember, ethanoic acid reacted with sodium hydroxide to form sodium ethanoate. That comes to 0.45. Now the next part of the calculation is straightforward. H plus equals Ka, which is 1.74 times 10 to the minus 5 times the concentration of ethanoic acid, which is 0.45 over volume. The volume is 0.5, so you can use 0.5 there. I'm just going to do it as I'm telling you now. And then the volume of sodium ethanoate is 0.05 over V, because we've already calculated it here. And that comes to, so if we do that calculation, 1.74 to minus 5 times 0.45 over V divided by 0.05, that comes to 1.566 times 10 to the minus 4, and then pH equals minus log of, so minus log my answer, and I get 3.81 as my final answer. Okay, now you may get an answer of 3.80 depending on where you round off. And that is end of this video on acids and buffers. Hope you found this useful. I will do a video on organic synthesis. I also intend to do one on mechanisms, electrode potentials, Arrhenius equation, rate, Kc, Kp. So that's all.